the next point. We should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Good day, learners. Welcome to yet another segment of e-learning organized by Kaduna State Ministry of Education. I am Monday Bakwe. I'll be taking you through the subject mathematics. And the topic of our discussion is number system. Number system. And the subtopic is conversion of fractions of decimal numbers in base 10 to binary. Conversions of fractions of binary numbers to base 2. Now, to convert fractions or mixed numbers, in base 10 to binary, which is base 2, as you know, we separate the whole number from the fraction and simplify as usual. To convert fraction or mixed numbers in base 10 to binary, which is base 2, we separate the whole number from the fraction and simplify as usual. Let's cite examples so that we can be able to solve to ascertain that definition. Convert each of the following binary numbers to binary. Convert each of the following binary numbers to binary. When we say binary, you should know it's base 10, and all natural numbers are in base 10. Question A, 13 whole number 5/8, base 10. 13 whole number 5/8, base 10. B, 9 whole number 3/4, base 10. 9 whole number 3/4, base 10. C, 0.625, base 10. 0.625, base 10. Question D, 473.5625, base 10. 473.5625, base 10. Then question E, 53.25, base 10. 53.25, base 10. Now let's see our solutions. Question A, we are to convert 13 whole number 5/8, base 10 to binary. From the introduction, I clearly spell out that we must separate the whole number from the fractional part. So 13 whole number 5/8 is equivalent to 13 plus 5/8. 13 whole number 5/8 is equals to 13 in base 10 plus 5/8 in base 10. Now you separately convert them. We'll first convert 13 base 10 to binary. Thereafter, we'll go to the fractional part. So as usual, we have our 13 divided by 2. The result is 6, remainder 1. 6 divided by 2. The result is 3, remainder 0. 3 divided by 2, the answer is 1, remainder 1. While 1 divided by 2, it cannot, remainder 1. If you do your manual calculator, 1 divided by 2 is 0.5. And like I told you, we are after whole numbers in this case. So start from the bottom. Our 13 base 10 will be equals to 1101 base 2. 13 base 10 is equals to 1101 base 2. Now we move to the fractional part, which is 5/8. Now we have to split 5/8 in multiples of 2 because we are converting it to binary. So 5/8 is the same thing like 4/8 plus 1/8. 5 over 8 is the same thing like 4 over 8 plus 1 over 8. Now you break 8 in multiples of 2. 4 in 4 is 1, 8 divided by 4 is 2. So you have 1 over 2 plus 8 is equivalent to 2 raised to the power 3. 2 raised to the power 3 is 2 times 2 times 2. And 2 times 2 is 4. 4 times 2 is 8. So instead of writing 8, we break it in terms of 2. So 2 raised to the power 3 is equals to 8. Why are we doing so? Because we want to convert the number to binary. And in conversion of number basis, 2 in base 2 is equals to 10. 2 in base 2 is equivalent to 10. Therefore, 1 over 2 will be 1 over 10. 1 over 2 will be 1 over 10 plus 1 over 2 cube will be 1 over 10 cube. 1 over 10 cube. Now, if you multiply 1 over 10 cube, 10 cube means 10 times 10 times 10 in 3 places. And that will give you 1,000. So we'll be having 1 over 10 plus 1 over 1,000. If you divide that correctly, 1 over 10 is 0.1 plus 1 over 1,000 is 0.001. 0.001. So adding them together, you have 0.1 plus 0.001 is equals to 0.101. Therefore, 5 over 8 in base 10 to binary will be equals to 0.101. 0.101 in base 2. Now, coming together to add them, because 13 base 10 plus 5 over 8 base 10 give us the whole number as a mixed number, which we are having 13 whole number 5 over 8. So 13 itself converted to base 10 is 1101 base 2 plus 5 over 8 converted to base 2 binary is 0.101 base 2. So 13 base 10 to binary will be 1101 base 2 plus 5 over 8 in base 10 to binary will be 0.101 base 2. Adding them together, you will be having 1101.101. 1101.101 all in base 2. Therefore, 13 whole number 5 over 8 in base 10 converted to base 2, you will have 1101.101 base 2. That is our final answer. Then we move to question B. Question B, we have to convert 9 whole number 3 over 4 base 10 to binary. 9 whole number 3 over 4 base 10 to binary. We split them, the whole number and the fractional part. The whole number there is 9, so we have 9 base 10 plus 3 over 4 base 10. 9 base 10 plus 3 over 4 base 10. Converting 9 to binary, 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2 itself, remainder 0. 2 divided by 2 is 1, remainder 0, as you can see. Then 1 divided by 2 is 0, remainder 1. So 9 from base 10 to binary will be equivalent to 1001. That arrow is indicating you start from the bottom. You start from the bottom and you go up. So 1001 base 2. So our 9 in base 10 is equals to 1001 base 2. We now move to the fractional part. Our fractional part is 3 over 4. So we have 3 over 4 broken into 2 over 4 plus 1 over 4. 2 over 4 plus 1 over 4. And 2 over 4 is equals to 1 over 2 because 2 is a common factor, plus 1 over 2 square is equals to 4. 2 square is equals to 4. So 2 square is equals to 4. Now 2 in base 2 is a clearly fact that any number in its base is 10. So 2 in base 2 is 10. We'll be having 1 over 10 plus 1 over 10 square. 1 over 10 plus 1 over 10 square. Now 10 square is 100 because 10 times 10 is 100. So we'll have 1 over 10 plus 1 over 100 put together by simplification. 1 over 10 is 0.1. 1 over 10 is 0.1 plus 1 over 100 is 0.01. 0.01. Therefore, 3 over 4 in base 10 is equals to 0.11 because if you add 0.1 plus 0.01, you have 0.11. Don't mistakenly say 0.11. We don't read mathematics in that way. After decimal point, you count the digit one by one. So our 3 over 4 base 10 to binary will be 0.11 base 2. So coming now to add them together, because we splitted the whole number and the fractional part. We'll come back to join them together. 9 base 10 is equivalent to 1001 base 2, while 3 over 4 in base 10 is equals to 0.11 base 2. If you do your simplification very well, 1001 plus 0.11 base 2, the result is 1001.11. 1001.11, all in base 2. Therefore, the final result, converting 9 whole number 3 over 4 base 10 to binary, it will be equals to 1001.11 base 2. So we have succeeded in converting 9 whole number 3 over 4 in base 10 to binary to be 1001.11 base 2. Question C. We have 0.625 base 10. We are to convert to binary. The first thing we do is to convert the decimal number to fraction. Convert that decimal number, which is 0.625, to a fraction. Therefore, the rule, if you have 3 digits after the point, you divide by 1,000. If it is 1 digit after the point, you divide by 10. If it is 2 digits, by 100. 3 digits by 1,000, and so on and so forth. Now, in this case, 0.625, there are 3 digits after the point. So if we are converting it to fraction, we'll be having 625 over 1,000. 625 divided by 1,000. When we reduce it by common multiple HCF, you still have 25 over 40. There is still a common factor. 25 divided by 40 is equivalent to 5 over 8 because 25 divided by 5 is 5, while 40 divided by 5 is 8. So the whole question, 0.625, fractionally is equivalent to 5 over 8 base 10. Now we move ahead to convert 5 over 8 in base 10 to binary. And how do we do that? You split the numerator in multiples of 2. Split the numerator, 5 over 8, the numerator there is 5. The denominator is 8. So you must try as much as possible to break all the numbers in multiples of 2. So 4 over 8 plus 1 over 8 will give you 5 over 8. If you divide 4 and 8, you have 1 divided by 2 plus 1 over 2 raised to the power 8. We break 8 in multiples of 2 and 2 raised to the power 3, you will get 8. Now, following the procedure, 2 in base 2 is 10. We'll be having 1 over 10 plus 1 over 10 raised to the power 3. 1 over 10 raised to the power 3, which is 1,000. 1 over 10 raised to the power 3, you will be having 1,000. So dividing it now, we have 1 over 10 is equivalent to 0.1. 1 divided by 10 is equivalent to 0.1 plus 1 divided by 1,000. If you divide very well, the result will be 0.001. 0.001. Now, summing them together, 0.1 plus 0.001, you will have 0.101 base 2. 0.101 base 2. Hence, our result, 0.625, converted to base 2, will be equals to 0.101 base 2. 0.101 base 2. Then the next question, which is question D, we are expected to convert 53.25 base 10 to binary. 53.25 base 10 to binary. We change the decimal fraction to fraction. I have just explained that if you have 2 digits after the point, you divide by 100. If it is a digit after decimal, you divide by 10. If it is 3 digits, you divide by 1,000. In this case, we have 2 digits after the decimal, and then we'll be having 53 whole number, that 25 divided by 100. 53 whole number, 25 over 100. Now, by simplification, 25 in 25 is 1, while 25 in 100 is 4. So the fraction becomes 53 whole number, 1 over 4 in base 10. Splitting it out, the whole part and the fractional part, we'll be having 53 base 10 plus 1 over 4 base 10. 53 base 10 plus 1 over 4 base 10. Then we'll move ahead with the whole number. You divide 53 by 2. 53 by 2 is 26, remainder 1. 26 divided by 2 is 13, remainder 0. Well, 13 divided by 2 is 6, remainder 1. You move ahead, 6 divided by 2, you'll be having 3, remainder 0. While 3 itself divided by 2, the result will be 1, remainder 1. 1 divided by 2 is not possible, so it will be 0, remainder 1. It can only be possible when you want decimal result. So from the bottom, as the arrow is indicated, from the bottom, 53 to binary will be equals to 110101. 110101 base 2. Then we are not done. We also have to convert the fractional part because they are together. And the fractional part is 1 over 4. 1 over 4, 4 itself is a multiple of 2. So we break 4 into multiples of 2. You'll be having 1 over 2 squared because 2 times 2 is 4. 2 times 2 is 4. But then we are dealing with number bases. 2 in base 2 is 10. 2 in base 2 is 10. So we'll be having 1 over 2 square becoming 1 over 10 square. And 10 square is 10 times 10. And 10 times 10 will give you 100. If we divide 1 over 100, the result will be 0.01 base 2. 0.01 base 2. Therefore, our 1 over 4 there become 0.01 in base 2. Now, putting together 53 base 10 plus 1 over 4 base 10. Of course, 53 itself is 110101 base 2. 110101 base 2 plus 1 over 4 in base 2. The result will be 0.01 base 2. You add them together, you will be having 110101.01 base 2. 110101.01 in base 2. Therefore, the final answer by converting 53.25 base 10 to base 2 will be equals to 110101.01 base 2. 110101.01 base 2. Then the last question, which is E, we have to convert 473.5625 base 10. 473.5625 denary to base 2. Now, the first thing, you change the decimal number to fraction. And in doing that, we'll be having 473 whole number 5625 divided by 10,000, because there are 4 digits after the decimal place. So divided by 10,000. We now move ahead to split the whole part and the fractional part. We have to separate them, so we have 473 base 10 plus 5,625 divided by 10,000 in base 10. If you divide that correctly using the highest common factor, you will be having 9 over 16 base 10. 5625 divided by 10,000 to the simplest form is equals to 9 over 16 base 10. Then we move ahead to convert the whole number now, which is 473 to base 2. You have 236 remainder 1, and then 236 divided by 2, you'll be having 118 remainder 0. While 118 divided by 2, the answer is 59 remainder 0. 59 divided by 2, you'll be having 29 but remainder 1. While 29 divided by 2, the result is 14, still remainder 1. 14 itself divided by 2, you'll be having 7 remainder 0. 7 divided by 2, you have 3 remainder 1. While 3 divided by 2, you have 1 remainder 1. Finally, 1 divided by 2 is 0 remainder 1. So 473 to binary, starting from the bottom as the arrow has indicated, we have 473 equals to 111011001 base 2. 111011001 base 2. And then we move to the fractional part, which is 9 over 16. In multiples of 2, we have 8 over 16 plus 1 over 16, which will be half. 8 divided by 8 is 1, 16 divided by 8 is 2. So 2 in base 2 is 10, and then 16 is 2 raised to the power 4, which is 10 raised to the power 4. If you add that, 1 over 10 is 0.1. 1 over 10,000 is 0.001. Therefore, 9 over 16 base 10, 0.1001 base 2. Adding them together, we'll be having 473 base 10 plus 9 over 16 base 10. The final result will be 11001.1001 base 2. Therefore, finally, 473.5625 will be equals to 11001.1001 base 2. That will be our final answer. Now, before we conclude, I will give you an assignment so that you can practice before we meet in the next class. The assignment goes like this. Convert each of the following denary numbers to binary. Convert each of the following denary numbers to binary. A. 17 whole number 3 over 8 base 10. 17 whole number 3 over 8 base 10. B. 13.625 base 10. 13.625 base 10. And finally, 95.125 base 10, which is question C. 95.125 base 10. I remain Mr. Monday Bokway. You can always get me through my phone number 080-2525-9755. 080-2525-9755. Stay safe, keep learning, and God bless you.